výborně. Hello everybody, I am John from BringAuto, and I decided to have just a small presentation about the dependency tracking and package managers for safety-critical systems in C++. And it's quite tricky because in C++, there are two most controversial themes you can have, and basically it's dependency tracking and it's backward or binary compatibility, yeah? Break or not break, use or not use. So every time I have the similar talk in any similar action, it's really interesting how many people in audience can think about the same problem with really different approach and really different point of view. Yeah, and basically it do the same in the end, but the way how we got there, it's completely different. Yeah. So basically, why I talk about dependency management? Yeah. I work for a company called BringAuto. We manufacture, develop, and operate last-mile delivery, autonomous last-mile delivery platforms. We are based in Brno, and we are almost automotive-ready company, basically. Yeah, so we really develop and manufacture real cars that weighs almost 1 ton and drives like 20 to 40 kilometers per hour. And for that kind of deployment, you need to be sure that your technology, your code, your hardware is safe. Yeah, not only the functional safety, but safe in a general manner. Yeah, so it must be reliable and it shall not harm people. Yeah, because if you harm someone, then it's not, there is no excuse for it. Yeah? And if it's not reliable, no one will buy it at all. Yeah? Because it's a real 1-ton weight car, and it's really expensive, and it's deployed in industrial or chemical plants for delivering samples, materials, and etc. So it's basically a machine, yeah? And it needs to last for 5 to 10 years. Yeah? So, what you need to achieve certain level of reliability, yeah, and safety is that your system needs to be well defined and your system needs to be predictable. Yeah? Because if your system is not well defined, then it means that you don't know how the system behaves. Yeah, in some situations that can impact the safety of the whole system itself. Yeah? And if the system is not predictable, it's, again, if your system is not predictable, it's not well defined, basically. Yeah. Yeah. So, and if you are able to manage well-defined and predictable system, then you can achieve that the system is safe. Yeah. In general, if you deploy really every safety-critical hardware or software, you need to go really deeply, step by step, and define what parts of the code, what parts of the hardware you need to achieve your goal. Yeah, basically, what dependencies you need. Yeah, what processors you need, what suppliers you need, what operation staff you need, and etc. Yeah, and of course, it implies that you need to track your dependencies, because if you do the big distributed system, then it means you will have a lot of dependencies, a lot of libraries, a lot of operating systems, a lot of deployed systems you need to maintain, and you need to know how the system behaves in each of these situations, basically. So, and in terms of dependency management, there are basically 3 categories. First category, because I'm a physicist, I studied theoretical physicist, yeah, you understand. And in physicists, we are in the first category. If it crashes, it crashes. Just run it again. Yeah, I don't care. Just run it again, and maybe it will not crash. Yeah, just if it crashes second time, just run it second time, yeah? So, because you don't need the type of safety like sec files and memory protection and etc. Because only thing you need that your computation is correct, which does not correlate in many ways with the memory safety and other stuff, you know? The second category is I care. I care about my system. I care how it works. I care how I solve my dependencies. But I don't want to overdo it. I don't want to have 200 people that do only the process management at all. Yeah? I don't want to have the strict processes because either I don't have money for that, or I just don't want to do that because it's really boring. Yeah? Because if you don't need the process, and there is no significant add value in the process, just don't do it, yeah? Because it has a lot of overhead on the way. Yeah? And the third category is I want to build a space probe. I want to build a control unit for a Boeing airplane. I want to build a black box for my nice train locomotive, and etc. Yeah? And we, as a BringAuto, are basically in the second category. Yeah? We are in the second category. We are almost on the edge with the third category, but we don't want to overdo it. Yeah? Because we are a small company. We have 30 employees, and for the really good process management and really good automation, stuff and testing, you need skilled managers, you need skilled testers, you need skilled engineers, and you need that everyone will buy your ideas that it's needed, that the process and all the overhead around is needed. And if they don't buy it, and if they don't follow, then it doesn't matter how much process do you, or yeah, how many processes do you have. Yeah? So it's a really complex thing, and every project that has more than 3 programmers, it's about project management, it's about process management in some level, it's about automation, it's about testing and etc. And more programmers you have, then it increases exponentially. Yeah? And it's not easy to maintain, yeah, basically. If we think about dependencies, basically, in general, we have 2 types of dependencies. Yeah? Local dependencies and system dependencies. System dependencies are dependencies which are part of the system itself. Yeah, like OpenSSL, libc library, kernel, and other really important libraries like pthread, libpthread, and etc. Yeah, and then you have local dependencies that it's not needed to be part of the system itself, because you don't need them, because on your system or Linux system distribution you certified, it can run many programs with many different dependencies, and even the same dependencies can have different versions. Yeah, and you can have 2 programs that can have they can use the different versions of the same dependency. Yeah, for example, the boost, Lowman JSON, speedy log, and etc. Yeah, for example, in BringAuto we use 3 versions of boost for each of our critical infrastructure. Each of the boost is verified and validated, so we need to know which bugs are there, which vulnerabilities are there, and etc. Yeah, but it's not needed to be part of the system, because in some cases, program A uses boost 178, program B uses boost 180, and we updated the version just because the old version of the boost, or the older version of the boost, had some kind of bugs that was not easy to repair without a lot of work. So we just updated the libraries and say, okay, this version of the boost doesn't have these bugs, and we left the old version with the program A because we didn't use the subsystem, yeah, that had the bug. So basically, it's not needed to update the whole library at all. So we had 2 versions of the boost. Yeah, and basically, what do you need to track about your dependencies, about your libraries at all. Yeah, it's a vulnerability. Vulnerability. Yeah, everyone understands. And is my dependency safe? And what does it mean? It's safe. Memory safety, functional safety, in the term of the library, is how it will affect the system, how it will integrate with the system. Yeah? Can it break something outside of the system? Yeah, in some manner, like can it overflow the memory if you use the QEMU? Can be there some problem with virtual paging and etc. Yeah. So and if you want to certify these systems, and if you want to have the system that has some level of reliability, you need to take in mind all of these issues. Yeah. That because you need to know how the system works in detail. Yeah. It's not possible to just use some dependencies from the internet and say it works. Yeah, it works. Yeah, because 3 people use it, so it works. So it's not possible like that. So and how will we use it and how will we approach of this problem in BringAuto? Basically, many companies and many, certainly smaller companies, use a lot of like Conan, like VCPKG and etc. Yeah, and the problem of these systems is that are really complicated. Yeah. These systems are really complicated, and in many cases, it's not easy to learn how it works in detail. If you want to learn how the Conan works inside, you need to go to the code and you need to learn how the code works. Yeah? If you want to freeze the Conan, it's not easy because it's Python code, mostly. Yeah? So you need to freeze your Python version. You need to freeze all of these dependencies. You need to ensure that these freezed versions or this distribution of Python you made for the Conan works as expected. Yeah? Even if you update your kernel, even if you update your libc library and etc. So it's really not easy to use it in a reliable system or safety-critical systems, because one of the points of the certification is that you are reproducible, basically. If you have a bug, you must be able to repair it. Yeah? It's not possible if someone says you have a critical bug in your system, in your drive-by-wire system, and I say, oh, I don't have a source code, and then say, oh, that's a really big problem, yeah, and it's basically not possible. It's not possible. It needs to be reproducible, and if you have a bug in your system you developed 5 years ago, you need to be able to repair it, yeah, because it's a critical system. In BringAuto, we, of course, use the source libraries as a submodule, and of course, we use a dependency manager. But all of these dependency managers that are publicly accessible or are open source are not bad. Yeah, I like Conan. I like VCPKG. I like all other alternatives. They solve a lot of the problems. But the problem is that in C++ community, each of the industry, each branch of the industry has different point of view. Each branch of the industry, even each company in the industry, approach to the problem in different manner, has different development workflow, and has a different need, yeah, because, okay, now I just do the control units for airplane, but the second company just don't do the control units for airplane, but do the recording units for trains, and all of these are certified by the same base ISO standard, but they divert in the time. Yeah, basically, even if they are based on an ISO standard, and they can be different need and different history and experience of these companies and etc. So in many cases, it's really hard to integrate these systems safely into your chain. Yeah, and the second thing that is really, from my point of view, for my company, is really harmful, or not harmful, but not good, is that to learn how the Conan works for a new guy, yeah, in that detail, because I want to recertify it, it's like for 2 or 3 months, yeah, because basically there is no detailed documentation, there are no requirements, yeah, of the system, so you don't know how the system should formally works. Yeah, you don't have any formal model on that. Yeah, you just have the great engineering work of the Conan, but you don't have the base. You can say, okay, now I exactly know how the Conan works, and if I want, I can rewrite it to any language I want. Yeah, that kind of documentation basically doesn't exist in such detail. In BringAuto, we've got a different way. We say, okay, we don't want to use Conan, we don't want to use VCPKG. We want to have simple dependency tracking system which is based on the CMake. Yeah, and only CMake, nothing else, because everyone who uses C++ knows CMake, and 80% of the projects are written in CMake as a configuration tool. Yeah, and in my company, in our company, we use CMake for basically in Golang, we use CMake for Objective-C and etc. So we just want to have some simple dependency tracking system that check consistency, that track dependencies, and that has some formal model which we can build on in the time, yeah, in long-term period, basically. And because it has a formal model, and because it's written in CMake, and because it has this formal documentation, then it's really not really easy, but much easier to understand and use than, for example, Conan on other stuff. But it's used only for CMake, and it's used mainly for C++ projects. So it's not general so much as a Conan. You know, you can use it on Windows, Linux, Mac OS, and etc. But it's just a dependency tracking system. You just have HTTP URI, and you can say, okay, I have these keywords, I have this URI, I have these variables, and it just downloads the dependency, cache it under the keywords, and then after you want to rebuild your build directory or reconfigure your build directory, you don't need to download them again, and etc. Yeah, so it's just dependency tracking system that ensures that all of the stuff is consistent, that you don't use the two different versions of the same library, that you don't use the same library with different remotes and etc. Yeah. And this is how it works. This is just a small example. Just clone it, export CMake lib there. It's the way how the CMake manage these find package libraries. Yeah, find package and add dependency. Yeah, if you add the same dependency twice in the project, it will say, you have this dependency twice. I cannot do that. You cannot do that. Yeah, you cannot have the same dependency with different keywords, basically. Yeah, or with different type and etc. Yeah. That's the example for using Boost. Yeah? And as we see, it just exports the Boost root, and the find package Boost just look at the Boost root and finds all of these components. And on top of that, on top of the CMake lib, we build a packager. Packager is just a Golang application that just take your command line arguments for your CMake project and builds it in the Docker and creates a zip archive. And uploads it to the Git large file storage repository you have in the top of your company, or yeah, just Git large file system. It's standardized and it's customizable. So if you have different naming of your package, if you have different need in your company, just go there, you fork it, you just change the class that creates these packages, and you have the exact naming, the exact structure you need. Yeah, so it's fine-tuned tool that's useful, and it's only one purpose. It doesn't do 5, 3, 4, 2 things. It do just one thing. It just takes a CMake project, configures it, builds it, and it installs. And from the install, it creates a package. Yeah, a zip archive, basically. Yeah. So, and basically, that's how it works. You just create your large file storage repo. In it, you just build BringAuto package builder. You build a Docker container from the configuration directory, for example, Debian 11, and then you just say, okay, I want to build package, all packages from the context example for the Debian, and I want to store them in the LFS repo. And you just go through all of these definitions and just say, okay, 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 I just built Zlib, I just built Boost, I just built Paho MQTT and etc. and just uploads it or store it in the Git LFS, and then you just go to the Git LFS and you just go type git push, and it's all. Basically, then your dependencies are built, and it's in GitLab, and you can download it if you want. And that's how does it look? How it looks like. And basically, the left side is something inspired by the standardized JSON format of the Conan, which I hope will be standardized as in C++ ISO. And we will be able to use it as a standard for metadata exchange between different build systems like CMake, Meson, Visual Studio, and etc. And it you just get your URI, you just go to revision, you just say, okay, it's a library, it's develop, you just say how the package should look like, and it's basically all. You just copy your command line into the config file, and that's all. And then you have Docker metrics, and you say, okay, for all of these images, I want to build it. So basically now, if one of our students just came and said, okay, I just installed Ubuntu 23.10, it's so cool distribution, I said, but we don't have dependencies for that. We don't know what's the consequences. But I install it, I want to try. So if we say, okay, why not? Just build a dependency and see how it works. So I just go there, I just run the command line. Yeah, I just run the command line with the, instead of Debian 11, I just write Ubuntu 23.10 and wait, I think it was like 2 hours, and then I just push it and it starts working, basically. Yeah, with the same versions of the library, with the system compiler, because we compile everything by the system compiler because we want to be compatible as much as possible. And then on the right side, you see how the structure looks like, and on the bottom, you see how it's used. And that's basically all. It's just the bottom part of BA package library, it just look at the remote for these zip archives, just download these zip archives, unzip them, and update the CMake prefix path for them. And that's all, basically. And then you can use just find library, yeah, or find package, yeah, in the CMake, and everything works as is your dependencies installed on the base system as a system dependency. Yeah, there is basically no difference. Yeah, so this is how we do that. Yeah, it's simple. It's one purpose. It's well defined. Not a replacement of Conan with CPKG. It's totally not a replacement of any of these technologies, because we don't aim to replace it. We want just simple dependency tracking for our projects, because our projects are closed. They have the autonomy that has its own dependencies. We have our fleet protocol that has its own dependencies. We have our drive-by-wire protocol, which has its own dependencies. And each of these projects has its own set of dependencies. We deploy, and we are able to maintain and predict and analyze and etc. So it's easy, because then you have a team of the programmers that programs, for example, firmware for your drive-by-wire, and they know, okay, I need these 8 dependencies to make it work, and then you can go and say, okay, this version of dependencies are okay with this compiler, okay, it works. You use this ECC, okay, yeah, and you can verify it completely independent on other projects. Yeah, so it's not it's really fine-tuned tool which is used by BringAuto to be able to maintain and achieve the certain level of reliability of our systems. Because if I have the one big dependency manager with all dependencies for all my projects, I'm not able to do that. We tried, and we were not able to do that, because it was really mess in manner that each programmer has its own opinion how to use these programs, how to use the Conan, yeah? And even if you have the processes and standards, every time someone just find a really good way how to do it differently and break something in the background, and you find it in the end of the process, yeah? And our BringAuto packager is just one purpose, simple tool that do just one thing, do it one way, and there are no possible shortcuts, basically. Yeah. And a lot of our technologies are basically open source. Yeah. So if you want, just follow us on GitHub, and I'm still to discuss about your favorite package manager and what's your opinion of tracking C++ dependencies, or what's your experience. Yeah, because in many cases, it's like that each company, each developer has its own opinion, and it's really hard to find some conclusion on consensus on the matter. And it's like when you talk with someone on CPPCon and it says, I don't want to break a binary compatibility or backward compatibility of C++ because this feature I used in 2003, and now I just remember and I will use it tomorrow. Yeah. So it's really interesting how the community can be conservative and open in the same way. Okay, so that's nice. That's all from my side. And is there anyone who has a question, who doesn't agree with me, or has another or different approach, different opinion? No? Yes?
I can. How far in the history can you go with this? Like, can you reproduce a build from 2 years ago? Is there some kind of cache? Because
yeah,
like the dependencies have other dependencies, and that like in the end have to be external, or you have sources for everything?
It depends. If all of the dependencies tracked by our packager are local dependencies, and if the dependencies are non-local, they are system and are part of the operating system. And if I need to repair bug that is 5 years old, I just go back and I look which system it used in deployment. I just use the system, I just use the compiler. Yeah, I just start the LXC container, and I can build all my dependencies again if needed. Yeah, if for example there is a critical bug in libc library, yeah, and I have a patch for the libc library for my system, and I need to rebuild all of my libraries, I can do that. Yeah, because I have a Docker container or LXC container, and I can run the stuff there, and it will compile, it will run, and then I can recompile all my stuff around, basically. So, and of course, it's a Git, standard Git, so it's a full history, and in each project, when it's in maintenance mode, yeah, so it's not you don't implement new features in TC, then you just archive all of this stuff, and you need to have them in some storage, so to be prepared, of course, with some potential bugs in etc. Yeah, so.
Okay, thank you.